Hi guys, today I'd like to talk about hardening your Openshift installation on Azure. Um, One of the weird things is currently if you install Openshift on Azure, it's directly usable. Developers can directly start using it, but it's directly available on the internet, available for everyone to access. And usually enterprises choose Openshift because it's a enterprise ready product, and usually you don't want to have your enterprise product directly connected to the internet. So let me draw a short picture on how an OpenShift installation looks like on Azure. Um, Usually what you would have is you would have one vnet with two subnets. One subnet it's related to management like tasks and infra. Infra is really specific to an OpenShift installation because that contains a thing called routes. But let's not go into that. That's besides the point. And you got one subnet that contains the functionality for the agent nodes. In Azure, you have the concept of an availability set. An availability set is something in the data center that makes sure that you have separate feed or electricity, separate disks, uh, separate cabinets even. So, and within this availability set, you would have one or multiple nodes being responsible for your functionality. So in the case of the subnet with the nodes, it will contain your Kubernetes nodes, and here you would have the management nodes. So like I said, standard out of the box, your services or your nodes will be in an availability set, and in front of this availability set there will be a load balancer, and this load balancer will use a public internet address which makes it available through the internet. So here you have functionality to the internet. And like I said, usually as an enterprise you don't want this to happen. You want your nodes and your OpenShift installation within the confinements of your own on-premise network. So in this short demo I will install an OpenShift installation, and based on the OpenShift installation which comes out of the box, I will remove this public load balancer for you, and I will show you how you can make this available through a thing called an internal load balancer, making this available only within the confinements of your vnet. Later on I'll show you a trick how you can make sure that whenever someone deploys a new service and exposes that type load balancer, that it will not be able to create a public internet address. But that's later on. So first, let's start by installing the OpenShift cluster. If you go to my repository, let me clear this up. If you go to my repository, I've made some very simple shell scripts. Basically, those are wrappers around this article, which is how you can install OpenShift Origin on Azure. OpenShift Origin, as you might know, is the open source or the free version of OpenShift. So I just did steps 1 and 2, and now I'm going to call step 3. And this will kick off the installation script. So this will take a while. When it's finished, I will get back to you. Installation is done now. Let us go to the portal, refresh. We see within the resource group we just created all resources which were needed for the OpenShift installation. So let me sort that. Here we see availability sets for the infra, for the master, and for the nodes. We see all kinds of this. We see the key vault, which contains the private keys. Here we see a load balancer, and this load balancer is the public load balancer I referred to in my talk earlier, and then we have two public IP addresses. So like I said, the master load balancer is exposed to the internet with a public IP address. So this one, the master load balancer, is using this IP address. Let me prove to you that I'm able to access it just using an internet connection. HTTPS. So I need to accept the certificate. It's loading. I can now log in using the credentials I used during my installation. Okay. So let us go back now. So what we want to achieve is that this is not possible anymore. So we want to remove this public IP address, and we want to remove the public load balancer. So this is not possible anymore to access this through the internet. So what we will do is we just click on the master load balancer. We will delete it. That's one part. Then we will delete the infra load balancer. Once that is done, it's finished, then we can also delete the public IP addresses. But in the meantime, we can just add our own load balancer, and this load balancer will be an internal load balancer. We click on this one, say create. We call it internal load balancer. You make sure that we're on the right network, the right subnet. This is the master subnet, and then we will use the existing resource group, and we will use the same region as well. So it's creating the internal load balancer. Internal load balancer. It's done. Then you will see it will have this IP address. This is the IP address in the range of the subnet of the masters. I will configure a backend pool. Internal load balancer backend pool. And here I need to associate this with an availability set. And if there are, this is the master availability set. And if there are multiple NICs, I need to attach this to multiple NICs. But for now, we only have one master, and that's on 10.1.0.4. Push OK. So once that is done, we can move over to failed to say something went wrong over here. Let's just refresh front-end pool, go to the backend pool. Let's retry it. Availability sets. Go to the master availability sets. Go to the master NIC and then save it. Maybe it was conflicting with the delete action. Could be. Let's refresh. So it's taking a little bit longer than I would expect. Then we're going to configure a health probe, and in the health probe we say internal load balancer H probe. We are interested in port 443. That's a mistake. Let's go back to the load balancer. Health probe. Still busy updating. Creating the probe. Now we're going to the load balancing rule. That's the last part. We call it internal load balancer rule. Here we say we're listening to port 443. We will route it to 443. And here we're interested in the client IP. I say OK. So that's done as well. So we have configured the internal load balancer. And the last step, what we need to do now is removing the public IP addresses. Just say delete. And I also do it for the infra. I do delete. That's done. So let me now draw and let me first prove to you that we're not able to access the console anymore through the internet. When I'm going to this address, you will see that it's not available anymore, as this address is not on the internet. So this is Dutch for site is not available. So we removed the public IP addresses. We only got the internal load balancer. Let me go back to the drawing board and let's go back to the drawing board. What we have here is now a vnet. This is your Openshift vnet. And what in an ideal situation, what you would have is you would have here your on-premise environment, and you would have a connection through the internet with a closed network on Azure. So this would be your Azure environment, and what you would have is called, usually you would have something like a spoke hub model, which is a network architecture that's often used within large enterprises. So here you would connect to a vnet, which would be considered as your hub, and this hub will have many spokes, or maybe one case, and the spoke is also a vnet. And in this case, your vnet could be your Openshift installation, for example. So here you would have your Openshift installation, and you would connect these networks together with a thing called vnet peering. So I will show you how to make this connection available. So one of the main reasons why you would have such a connection, that your on-premise is using a hub network, and from the hub network you're going to a separate vnet or multiple vnets, is that you can, for example, share the costs of the connection. So for example, if you would establish a connection from your on-prem to your Azure environment, and you want to have it in a secure way, you can use a VPN, or you can use a thing called an express route, which is basically a dedicated line from your on-premise environment to your vnet. So this is quite costly, and as you don't want to have an express route connection to every vnet, you would usually use a hub, and from this hub you would connect multiple networks that are paired with this hub. So that is in a nutshell what we are going to show you. So in my case, I don't have an on-premise network. What I do have is a vnet that is called OS client, and this will be in my demo the hub. And I have my Openshift installation, which is having the masters in the one subnet and all the agent nodes in another subnet. And what I did is, for these masters, I exposed an internal load balancer on the port 10.1.0.6. So I should be able to, if I have on my OS Client Hub, I have two machines, one Linux machine and one Windows machine. I should be able to connect from this machine through the internal load balancer and access the management console of the Openshift. So let me show you that. First I need to pair my networks. So I'm going to the Openshift vnet network and I'm going to peerings, and then I'm going to add a peering. I'm going to call it Openshift to Openshift client, and here I say I like to connect to OS client. I will allow forward traffic. I can close that. Whenever you pair, you need to do it on both ends of the network. So now I'm going to the other side, and that's the Openshift client. I'm going to the network. Let me see, OS client network, and also here I'm going to peerings, and I'm going to add a peering, and this one I'm going to call OS client to OS. Then I'm selecting the Openshift vnet, and also here I'm allowing forward traffic. So once this connection has been established, refresh. Yeah, it's added. I should be able to go to the Linux client, which is connected to the OS client network. I'm going to copy the SSH commands. I can clear this. So with this public IP address of the client, I'm connected to the Linux client, and I already installed the Openshift CLI on this machine, and I can do now an OC login on 10.1.0.6. So initial connection can take a little bit longer than usual, or maybe there's an issue with the peering. Let's hope not. Another thing that's also possible is that I didn't remember the proper name of the load or the IP address. Let's go to the internal load balancer. It's 10.1.0.6. So it's saying it's not available. Front-end IP configuration. Loading backend pools. 10.1.4 or health probe 443. What did we say here? You're going from 443 to 443. So let me try again. HTTPS. I didn't add the protocol. So here I'm going to use again my cluster admin. I'm going to use the password I used during my installation. And here you can see I'm logged into the Openshift cluster with a machine that's connected to a paired vnet. So let's see, OC get pods all namespaces. Should be able to see the pods. Here we go. So looking good. Now let's go to the Windows machine. So the last part I'd like to show you is connecting from my Windows client. So here is the data of my Windows client. It's available through this public IP address. I'm going to use my Windows machine here to connect with a remote desktop. Remote desktop. Let me see. This is the remote desktop connection. going to connect to it. Yes, I can close this. So here I'm going to access the machine with 10.1.0.6, and I need to use the HTTPS protocol, not the JHT. I don't know if that one exists, but it's this protocol. And here you can see I can access the console. So all good stuff. There's one last thing I like to discuss with you guys. In order to harden your environment, you can also do the following. Here, let me see, do I have a notepad open? No. This is of course my remote desktop. I'm closing my remote desktop here. I'm going back here. Connecting to my local Windows laptop. My local Windows laptop still has the connection open to the Windows machine on Azure, so I don't want that anymore. Let me just, okay, this is my one moment to disconnect. So the last thing I want to talk about is, once you have your Openshift installation, you have your agent nodes. On these agent nodes you will deploy the deployment configuration, which will consist of many pods or one or more pods. Those will be distributed over your agent nodes, and then you will expose it as a service. And this service can have several types, but if you would expose this as type load balancer, then by default your installation will try to create a public IP address on the vnet. So you would have still the same problem that anyone who's deploying a deployment and exposing a service within your Openshift installation can still expose something to the internet. So one trick to bypass it is to tweak with the roles, so the RBAC of the service principal. So the service principal is the user we used with the installation when we set up the Openshift environment. And with the Openshift environment, we say, okay, we're using this application ID. This application ID is also responsible for running your Openshift installation. So if I say, okay, this service principal has certain RBAC rules, and in these RBAC rules I'm saying you're not allowed to create public internet addresses, you have a trick to or you have a way to secure your environment, that so that you know for sure that it's not possible to expose any services out to the internet. So let me show you an example of a role-based access I have in my GitHub. So let's go to my GitHub repository. Here you see a custom role I've created. So here you can see here is the scripts, how you can do that. And the custom role looks something like this. So here I am saying, okay, you can do everything within the scope of this resource group, but what you cannot do is create anything which is related to public IP addresses. So this was the last part of hardening your Openshift installation. Hope you guys liked it and found it useful. Please let me know in the comments section, and if you like it, please subscribe to my channel. Have a nice day. this is the end of my recording. Thank you very much.